Hello everyone, this is Mr. Huebner with an Earth Science video. In this video we are going to be working on doing ratios of celestial bodies and working with astronomical numbers. We're going to be preparing for the model that we make, hopefully in the parking lot outside if the weather's nice, where we can basically put the solar system and scale it down so that it can fit in a parking lot. But we got to do a little bit of math first. Alright, first I want to get one important definition is astronomical unit, also known as AU. This is common in astronomy. You're going to hear the word AU. And astronomical unit is the distance between the Sun and Earth. It's also known as 150 million kilometers. That is 1 AU, 1 astronomical unit. Alright, so talking about ratios, the Earth diameter versus the Moon diameter is a 4:1 ratio, meaning that it would take 4 moons to equal the size of 1 Earth. So here's a little visual drawing. There's the Earth. 1, 2, 3, 4. So that's about the size of our moon, one of those circles, based off of what we know of it and the 4:1 ratio. 1 Earth is equivalent to 4 moons in terms of diameter distance. Now we want to look at the moon distance from the Earth. A lot of times you think that it's right next door, really close. But if you were to take further than a bird's eye view, more like a Martian view or a space eye view, you would see that, wow, the moon is actually kind of far from the Earth. So looking at it, Earth to moon distance, 31 diameters or sizes of the Earth is how far the moon is from the Earth. So we're going to make the Earth really small. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, and we're going to make the moon right there. And just think about that. That orbit is going around really large in an elliptical orbit. And whenever you see pictures, you see, oh, there's the Earth, there's the moon. No, that is a lie. The moon's actually really far away. So when we set foot on the moon in 1969, that was actually a very, very large accomplishment to travel that many Earths from Earth. Alright, so moving on. The Sun diameter versus the Earth diameter, there's 108 Earths that could go string along the Sun. 108 of them. And just, that's huge. So the Sun is not a very large star compared to a lot of the other stars in our galaxy and universe, and we'll study that in the coming weeks. But compared to the Earth, it's huge. 108 Earths is the diameter, the distance, the belt around the Sun. There's no belt around the Sun, but that's an analogy. Alright, moving on to the next one. It says Sun diameter to Earth to Sun distance. So what this is saying is, if you have one distance between the Earth and the Sun, that's 1 astronomical unit, that's 150 million kilometers. you're going to need 107 sun diameters. So if you need 108 Earths to be the diameter of the sun, you're going to need 107 of those to make your way from the sun to the Earth. So very, very large. All right, let's do some examples of this. All right. If the Earth were 3 centimeters, what would these be? So let's say we got 3 centimeters. Okay, so the sun diameter, well, Earth is 3, so sun diameter. Where is it? Oh, sun diameter. There's 1. It takes 108 Earths. So that's our ratio that we're going to be using. And the Earth is 3 centimeters. So I'm going to write down 3 centimeters times 108 Earths per 1 sun. Alright, when I calculate that out, I would need a calculator. So I know 3 times 4 is 24, and 3 times 1 is 300. Or you just punch in your calculator. Yeah. So really, if the Earth is 3 centimeters in diameter, then the sun would be 324 centimeters in diameter, so significantly larger, much, much, much larger. We want to look at the Earth to sun distance. All right, we got Earth to sun distance. For every one of those, there are 107 sun diameters. 324 is our sun diameter. So I'm going to take 324 centimeters times 107 suns per 1, Earth-sun distance. So when I do that, I could punch up my calculator, 324. Why don't I just do that real quick? Let's see, calculator, 324 times 107. It's a big number, 34,668. 668 centimeters. So the Earth is 3 centimeters in diameter, the Sun is 324 centimeters, and the 150 million kilometer astronomical unit distance from the Earth and the Sun is 34,668 centimeters. Let's do the Moon diameter, going a little smaller. Got 3 centimeters is the diameter of the Earth, but the Moon is basically 1/4. It's a 1:4 ratio. So I'm going to multiply this by 1 Earth for every 4 Moon, which is going to be 3/4, or 0.75. And that's centimeters. So the diameter of the Moon is 0.75 centimeters, where the diameter of the Earth is 3 centimeters. Then the last one, Earth to Moon distance. Where do we have Earth to Moon distance? That's 31 Earths per 1 Earth-Moon distance. So let's see. Got 3 centimeters times basically 31 Earths per 1 Earth-Moon distance. So 3 times 31, that's about 93. That's a lot. 93 centimeters is the distance from the Moon to the Earth if the Earth is 3 centimeters in diameter. And really, that's still smaller than the Sun. So the Earth-Moon orbit is smaller than the actual Sun itself. All right, so moving on, this is to the actual activity. So this little worksheet right here, where we're doing conversions, and it's the same thing, only with the real actual numbers. So right there, Earth distance from the Sun is 150 million kilometers. The Earth diameter itself is 12,800. So why don't we just start with that? 1 million kilometers is going to be equivalent to 1 centimeter. So what I'm going to do, let's start with the diameter, 12,800. I'm going to take 12,000, and these are all in kilometers, 800 kilometers, and I'm going to put km on the bottom and centimeters on the top. I always put what I want on top and what I want to get rid of on the bottom. And how many kilometers are in a centimeter? I mean, this isn't truly converting from one unit to the other in the metric system. This is our make-believe scale. So we're going to say 1 centimeter equals 1 million kilometers. And essentially, I'm going to take 12,800 and divide it by 1 million. All right, let's do that. Hey, Emily, 12,800 divided by 1 million. And that's 0.0128. Scale distance, scale diameter. 0.0128. Well, that's a very small number of centimeters. Well, in our activity, if we can do it outside, we're just going to put it, a dot. And maybe for fun, we'll put a big circle and say, that's the Earth. Because we're going to need a big circle to see it when we're all the way by Pluto. So, and if we don't have a nice weather, we will do it inside with blue painter's tape. We'll get the same idea. It won't be as fun as going outside, but let's do 150 million. So 150 million, we do the same way. We multiply by 1 centimeter and divide by 1 million kilometers, because we want to end with centimeters, which is what our scale is, our model is being scaled down to. Alright, so, and some people probably do this in their head. If that's not you, that's totally fine. 1, 2, 3, divided by 1 million. 1, 2, 3, 1, 2, 3. And that's 150. So we're going to put that right there. So 1 astronomical unit is 150 centimeters. And, 150 centimeters, that's not too long. 1 astronomical unit. And this is going to be, it's going to fit in 1 parking space. But we're going to find out that might not be the case. I don't want to ruin the surprise. Oh my gosh. Okay. Sorry. Sometimes when I make these videos, I don't show what's going on. Hopefully I showed what's going on. I'll go back to review it. But anyways, there we go. That's what I wanted to have happen. And you can see all of these. Look at that, 780 million. Whoa, is that 1.4 billion? Yeah, it is. 2.8 billion, 4.5 billion. Pluto's 5.9 billion kilometers. Oh my gosh. So, if you feel like you know what's going on, great. You can kind of move on. You can skip watching the video, but if you need a joke, chemistry, look at that. It's kind of true. Otherwise, we need another kind of example. Stay right here. Why don't we do Mars? Mars is fun. So Mars is 228 million. Yeah, 228. 1, 2, 3, 1, 2, 3. Times it by 1 centimeter, divided by 1 million kilometers. And you plug it into your calculator, and you should get 200 28 centimeters when you plug that into your calculator. Right, 228 scale distance. All right, and then you'll do the diameter times it by 1 centimeter divided by 1,000,000 kilometers. And in this case, basically 6, 1, 2, 3, 4, 5, 6, 0068. And you just type that into your calculator. 6,800 times 1 divided by 1,000,000 will get you something around 0.0068. And Mars is significantly smaller than the Earth, and it looks like we did our math at least somewhat correctly because it is smaller than the Earth. All right, keep on trying. If you have questions, you can email me, and we can set up a Zoom call and get that taken care of. All right, hope you had a great time during this astronomical talk, and I will see you later.